So, good morning once again, and thank you for joining. We can get started. And today we will have a session on collaborative robotics for machine tending. The agenda today, we will have Mr. N. Ramchandran, our Managing Director, who will have a brief introduction and a context setting, followed by a presentation by Doosan, Mr. Yong Hee Lee. We would subsequently have a presentation by Mr. Niels from OnRobot from Singapore. And I would then make a presentation on behalf of MELSS, followed by a question and answer session. Ramchandran, sir, over to you. Sir, you are on mute. We can't hear you. Sorry. No, we can't hear you yet. We can see your video though.
Office invitation. Well, here now it's okay. Thanks. Good morning, everyone. My apologies. There's some technical glitch. Am I audible?
Yes, sir. We can hear you.
Thank you. Good morning, friends, and Mr. Lee, and all the friends. Friend from OnRobot, Niels. It's a great pleasure from MELSS to host this seminar on cobots. As you all are aware, Industry 4.0 is a big subject, and there's a huge interest in the industry on Industry 4.0 for many reasons, for more than one, in terms of efficiency, better throughput, worker safety, availability of the workforce due to changing environment in the world in terms of COVID, etc. So robots and cobots are really starting to play a great role in our quest for Industry 4.0 and efficient manufacturing operations. And from our side, MELSS, we are promoting the Industry 4.0 intensely with all the industries. And we have been talking about and making presentations on Industry 4.0 on many occasions. And this occasion, we have picked up to get the world leaders in this game to make a detailed presentation to you in terms of the concepts, in terms of how optimally these concepts can be used for various applications. So it's a great pleasure for us to get them to make this presentation to all of you. And in this context, one of the things which we encounter when we talk about digitization, robotics, etc., is in terms of the payback period. The payback period is an important element in any capex decision of an industry, and we closely work with the industry to see how this payback period can be as low as possible. there is a general impression that cobots are expensive and the payback periods can be longer. It is far from the truth. Cobots are not very expensive. They have their cost in terms of what it requires to make the Kobo better and give all the specifications which are required, but they are not very expensive. And the payback periods can be even as low as 12 months to 18 months if we configure them effectively. That's where MELSS comes into picture. We can help the industry to configure it properly, put the proper jigs and fixtures, and work out the configuration in a way that it delivers extremely good results and a very low payback. So I would like to really stress on this point that cobots are extremely helpful in the shop floor. They can work along with people. You don't require fencing and all kinds of protective equipment when you work with cobots, and they are human-friendly devices which they can really easily install, and they're light. You can even move them around at will, and so you can mount it on a wheeled platform, so you can move them around and take them to places where the workload is more, shift it out to places where the workload is less. It's the most convenient and efficient device. So, these two gentlemen will make a detailed presentation on this subject, and Shiva will be talking about our contribution to configuration and the efficient delivery of these concepts. So you're going to have an excellent session and for next 2 hours, and I'm sure all of you will enjoy, and we all the best to you. Have a nice day. Thank you.
Thank you very much, sir. So I would now like to introduce Mr. Yong Hee Lee from Doosan. Mr. Yong Hee Lee has worked at Doosan Robotics since 2018 and is part of the global sales team. He is responsible for the sales in Asia, MEA, and Africa. He holds a bachelor's degree in engineering. He started working in project management and execution for a subsidiary of Doosan Group, and he's been with the group for the last 10 years. Doosan Robotics started selling collaborative robots in Korea in 2018 and has been continuously expanding its overseas sales as a global collaborative robot manufacturer. Over to you, Mr. Yong Hee Lee. We can't hear you. Sorry, you're on mute.
Sorry. Yeah, I will continue. Yeah. Firstly, thank you for joining and also invite to me for this webinar. And also, I'm so great to meet everyone. And also, I'm so happy to keep receiving the this opportunity for introduce our robot and also some cases. So, firstly, thank you for Mr. For introducing my resume or some introduce. So today's subject is I will introduce Doosan Group, which company is Doosan Group, and also what is this collaborator robot, and also Doosan's collaborator robot characteristics and advantages. And also I will introduce some cases for using machine tending application. So it takes around the 10 to 15 minutes. So thank you for your concentration in advance. So I will prepare my presentation and also start my presentation just for a second. Okay, again, thank you and attending this meeting. And also I'm so glad to have the opportunity to introduce the company and products through this presentation. I hope that this time to be opportunity to you, all of you, for understanding Doosan and Doosan Robotics better. As I mentioned before, it takes around 10 to 15 minutes. Then after presentation, I will share some cases for machine tending with the Doosan robot. Yeah, firstly, I will start with introducing Doosan Group and Doosan Robotics company. Doosan Group is a registered company in the Fortune Global 500. The group revenue and employees are mentioned in the left side of screen, and representative companies are machinery manufacturers such as Doosan Heavy Industry and Construction and Bobcat. Also, within the Doosan Group, there are many subsidiaries involved in many fields such as machinery and part manufacturing and construction and energy. And Doosan Robotics is belong to the machinery category, as you can see on the right side on the screen. Doosan Robotics was started in 2014 and was established as an independent company with the support of Corporation Group. The head office is located in Suwon, South Korea, and we have one production plant with a 10,000 unit as a maximum annual production capacity. More than half of them are belong to R&D engineer, and we developed and improved hardware and software of robot with them. And also, we have partners in more than 40 countries all over the world, including India market, and we are continuing to expand overseas business partners network. Also, warehouse is located in Netherlands and USA for the supporting our partner. From this page, I will introduce the Doosan Collaborate robot lineup and the feature of each product. Doosan Collaborate robot consists of 3 series, M, H, and A, and the value proposition that each lineup aim is mentioned on the screen. The A series aim to speed, efficiency, and the M and H series are safety and precision with torque sensor. From the left side, the M series, which called masterpiece model to us, it has 6 torque sensors in each axis. With that, force and compliance control can be done and useful to more precise work. And H series, with high strength and payload specification. Lastly, A series, which aim to realize fast ROI with the speed, efficiency, and cost effectiveness. Doosan Collaborate robot consists of 10 models, as you can see the graph. We intend to satisfy customers' requests with the most various lineup among the present covered companies. I will introduce the characteristics of each series with the next page. First of all, I will introduce M series as a representative model. Above all, it is designed that is focused on safety. Each axis has a torque sensor for the precise working as a human being. And according to international standard, the highest level of safety function has been certified. And also, intuitive user interface and easy programming to be make customer for being familiar with Doosan robot. As I mentioned before, one of the characteristics of M series, the torque sensors allow you to perform precise work similar to a human being. Particularly, it can be said that force control and compliance control among product scale are the biggest advantage using torque sensor. Through this sensor, precise work such as polishing and gear assembling is available without any damage and the appearance of the product. Secondly, the H series. This model has the highest level of payload and safety among cover specification comparing with similar specification robot. Considering payload and reach, it can be compete with industrial robot. The H series has 25 kg of payload and is widely used for heavy material handling and palletizing. And also compared to the other robot with the similar specification, the robot weight is not too much heavy, so it is easy to install, reinstall, and integrate with a mobile robot such as AGV or AMR. The H series also has 6 torque sensors on the each axis for safety and usability, same as M series. You may think that H series is like an expansion model of M series. The basic composition of M and H series is robot arm and teach pendant for programming and controller like main server roles such as power supply and communication. Finally, A series. A series is designed with increased velocity and acceleration of each joint. It is suitable for application which is required fast cycle time. Even though A series does not have torque sensor, the collision detection level is enough to sensitive comparing with comparative model, other comparative model. It also certified the same level of M and H series by functional safety. I will introduce and explain the later with that page. And also, past ROI can be realized with the work efficiency and also price competitiveness. As I explained with the previous page, pulse torque sensor can be selected and installed as an option to improve pulse control and compliance control on the 6th axis. When attaching a sensor, the letter S is added after the product name. Basic composition of A series is robot arm, emergency stop button, and controller. Basic programming is possible with laptop or PC. Additionally, customer can purchase the teach pendant or smart pendant that can easily control the pre-programmed task as an option. By now, I explained the feature of each series and characteristics. Then, what is the main reason for choosing Doosan Robot? And also, what is the advantage and competitiveness of Doosan Robot? With this page, I will summarize the advantage of Doosan Robot. Doosan Robot has the 3 competitiveness. One is super safe, second, super easy, and last, super flexible. So I will explain with the next page. Firstly, Doosan Robot has obtained safety certifications according to international standard for 20 safety functions. The safety level is divided into 5 levels. Some safety functions are certified with the highest level. So we achieved the performance level E and category 4 for the sum of our safety function. The next advantage is that it is easy. It is related to software that was developed by ourselves. For programming, teach pendant like a tablet PC is used, and it has an iconized user interface, so customer can make task easily compared to industrial robot of that. In addition, for the direct teaching, which is main function of collaborative robot, we have the button on the 6-axis, and direct teaching is possible immediately with this button. Finally, flexibility. With Doosan robot, this Doosan collaborative robot, it is not required on actual pens with by safety function and easy to install and reinstallation. With these characteristics, it is not required to large workspace. And also, we provide convenient circumstance of connectivity for EOAT or other tools. Therefore, the wide range of utilization will be provided to our customer. Also, as you can see on the screen, Doosan Robotics provide various accessories that can use according to the work environment or request to our customer. Finally, I will introduce to you some video of a practical application of machine tending. Let us see the video. There are more video, but please refer that this is Korean application cases. If you would like to see more examples, please refer to the Doosan Robotics official channel on YouTube. Just for a second, I will share this practical application. Thank you for waiting with my preparation. I will introduce to you some of the application. The number of video is 3. So as I mentioned before, there are more cases in our official channel. So first video is the application between milling machine and our Doosan robot. So instead of human being, robot working the raw material input to this milling machine, and after finishing this manufacturing and out of this machine by Doosan robot. So during the working by robot, human being worked for other works. So you can think it is a collaboration. Second case is collaborative robot with CNC machine and robot and human collaboration. So it also you can think the definition of collaborative robot and work. Yeah, when you see this screen, at that time, people working without some robot work. So you can think it is a collaboration. Doosan collaborate robot and collaborate robot is worked just beside of a human being. The last case is efficient operation with combined by 3 CNC machines and Doosan Robot 1. So it was make a layout for the considering efficiency. So the center of the CNC machine place the one of the Doosan robot with the longest reach. So it is worked continuously. Yeah, this is interview from the CEO in a Korean company. So I will pass this. He said it is satisfied considering the ROI and also work efficiency. Additionally, they have a more plan for this purchasing Doosan robot now. By this, I'd like to finish my presentation. As mentioned at the beginning of the presentation, I hope that you will understand the characteristics and advantages of Doosan Robot better than before. Thank you again for attending and pay attention to my presentation. Thank you.
Thank you very much, Mr. Lee. And I hope all the participants got a good background about Doosan cobots and how it can be used for machine tending. If there are any questions, feel free to type it in the chat box, and then we will address them at the end after all these sessions. And we can go through them. In the meanwhile, if there are some queries, we can address them as well. Okay. So I would now like to invite our next speaker, Mr. Niels Soresen. From OnRobot. Niels is a native Dane who has spent over 25 years abroad in different parts of the world during his studies and work assignments. Niels, currently based in Singapore, joined OnRobot in October 2017 and was their first employee in the APAC region and is in charge of OnRobot's partner network and business development across South Asia, Southeast Asia, and Oceania. OnRobot is the global leader in end-of-arm tooling for collaborative and industrial robots. Niels holds a bachelor's honors degree in marketing and international management from the International Business School of Groningen the Netherlands. During the past 22 years, Niels has worked for various SMEs and international companies in Malaysia, Singapore, Denmark, and Qatar, as well as has run his own consultancy firm for a period of 6 years, where he worked with and invested in startup companies in Malaysia and Singapore, as well as taking on consultancy jobs for local and foreign industrial clients. Niels has lived in Asia since 1997, where he has been working with primarily the industrial sector, selling technical services and products directly to end users, as well as through distributors and agents. OnRobot APAC currently has partners in 15 territories, where Niels personally handles 10 of these markets. So welcome, Niels, and over to you.
Thank you, Shukuma, and thank you to MELSS for arranging this this very interesting webinar. So today we are all talking about machine tending, and particularly machine tending in the collaborative setup. So let me start sharing my screen. Let's see. Are you able to see my screen?
Yes.
Yes.
Please.
Okay, let's go to presentation mode. Okay, right. So as mentioned by Shukuma, I'm working for a company called OnRobot. So we are basically a Danish company based out of a city called Odense in Denmark. And Odense is certainly for Indian standard quite a small city. There's about 220,000 people living in Odense, but it is kind of considered a Silicon Valley of robotics in the robotics industry these days. There is more than 130 robot-related companies in Odense alone, including Universal Robots, MIR, OnRobot, and so forth. So it's a very interesting city to be based out of in terms of our HQ. So today I'm gonna talk a little bit about who OnRobot is and what our vision is. Then I always tend to take a step back before going into the whole product part of it. So I'll just talk very briefly about safety when it comes to collaborative applications, and then talk about why machine tending, or rather why collaborative machine tending is growing very fast, and why it could be beneficial to you as a manufacturer. And then if I got time, I'll show a video or two just with some success stories from machine tending that we have been part of in the past. So OnRobot, as I said, is basically a Danish company, but we have been merged or bought over a number of companies over the past few years. So right now OnRobot is a mix of 5 different companies from Denmark, Hungary, and the US, merged into one big company. As I said, our HQ is out of Odense in Denmark. We are around 185 employees globally now, with R&D centers and production in both Odense in Denmark and Budapest in Hungary. Personally, I'm sitting in our Singapore office, which is the APAC regional office, but we also have offices in China, in Japan, and in Korea as well. So what's the vision? So I was actually one of the very first employees in OnRobot. I was employee number 13. It's been close to 4 years now. I've been with the company. So when I joined OnRobot, basically all we had was one gripper. It's called RD2 gripper. That's all we had, nothing else. Now the world of OnRobot looks very, very different. At that time, we were only able to integrate with one single robot brand, nothing else. And as I said, just one gripper. That was it. Now what OnRobot offers is basically that we are able to integrate with every single robot brand in the market. We have a target of being able to, or we want to be able to offer tools for all applications in the market. We are not quite there yet, but we are growing very fast. We want to have all accessory types, which is obviously needed if you're going to be able to work in all application types. And then finally, we want to be able to integrate in all industries, or rather all industries in all sectors. So one of the reasons we can do this already is that we are exclusively building, manufacturing, and selling electrical products. We are not touching pneumatics. That means, as an example, if you work in a hospital, you work in a restaurant, where for sure you probably do not want to install pneumatics. You can easily work with our end effectors. Also, if you're working with AGVs and so on, moving around with a robot arm in your production hall or in your warehouse, obviously you can't use pneumatics either, but you can easily use our tools. So these are one of the reasons that we are only working with electric end effectors. Now, as I said in my introduction, I just want to take one step back and just talk a little bit about safety. Generally speaking, and this has been a trend ever since the cobot started, people tend to talk about a cobot like it's the savior of the world. You know, as soon as you have a cobot, everything is safe. You don't need to worry about anything else. No fencing, no nothing. That is not quite true. When you talk about cobot setup or collaborative application, the whole system has to be safe, not just a cobot. And that, of course, includes the end effector as well, right? So when you talk about collaborative application, there are certain standards or specifications that you need to adhere to. You need to check and understand how to do it. Now, for cobot application in particular, it's the ISO TS 15066 2016. So it's not a standard, it is a specification. But basically, what it does is it gives you different information on how to do a proper risk assessment, for instance, what factors to look out for. As an example, I put here, when you talk about gripping, for instance, any gripper that closes with a force limit above 140 Newton is no longer considered collaborative, and you actually need to start fencing off your setup, even if you're using a cobot. So things like that you need to be aware of. Things like safety guards, switches, safety signs. As you can see here, all our grippers, all our end effectors generally are all round shape. You know, there's no way you can cut yourself and the robot arm moves around it in case it hits a person and so on. So all these things are very, very important to take notice of as well, if you are looking at having a collaborative application with no fencing. So collaborative machine tending, why would you look at that? Let's take a step back again. Majority of machine tending is still done manually. Yeah, that means you have person standing and say feeding a CNC machine in, and then taking out the product again and putting it into boxes and so on and so forth. One of the reasons, at least in the past, that it's been difficult for SMEs in particular to look at automation is that it's been very, very expensive. And Mr. Ramachandran also mentioned in the beginning that at least in Southeast Asia, cobots are still looked at upon as being very expensive. But if you actually go into the whole benefit of it, what you're able to get out of having a cobot or collaborative application in your space, you might relook at what you look at as expensive. So that is one thing. Another thing is that traditionally, many companies do not really have the right internal knowledge about how to automate, how to integrate robots, how to program them, what kind of end effectors to use, and so on and so forth. But one of the things specifically with cobots and collaborative end effectors is that it's made, and I want to take something Mr. Lee said in his presentation. It's made very safe, it's made very easy, and it's also made very flexible. So safe and easy are really two key things when you talk about collaborative applications. Yeah, it has to be safe, so you can work around people without being fenced off, and it has to be easy to integrate. I mean, we have end users that our distributors have literally just sold a cobot with some end effectors from OnRobot, and they have done the entire installation themselves. It took them a week just to learn how to integrate it, how to do the programming and so on. But 1 week they're all done, ready to go without any external help. That is really how easy it is and how it can be done. Another thing, and now we're coming to companies more doing into the, let's say, machine tending applications. Often you have more than one production process. So you might have milling, grinding, turning, laser cutting, lathe, and so on and so forth. So you might think, okay, where should we start the first? Or sometime I might have I might need to do more milling than I need to do turning. I might need to do more grinding and that I do laser cutting. What if I install it for milling only and then later on I want to change it to turning? If you do industrial way, where it's bolted into the floor, you have casing around and this kind of thing, changing from one production process to another is very difficult, if not impossible. It certainly takes a lot of time and money. That is another thing you're overcoming. High mix, low volume, especially for SMEs, right? It's typical. Today you do one product, next week you do another product, and then the next month you do a third product. So you always have to change, and that is also a thing that in the past at least have made automation very difficult. Mr. Ramanchandran also mentioned one thing: limitation of workers, or I'll say limitation of skilled workers. In this case, is something that is happening everywhere in the world, even in India, and not least during the COVID situation, which is still ongoing, right? Where you might have, unfortunately, you might have workers that have, passed away, or certainly not able to work at the moment. They're not able to get back to where the to where the factories and so on. And these are issues that are here now, but it's also issues for sure you're going to be facing in the future. It might not be called COVID in the future. It might be called something else, but this is not a one-off thing. So, future-proofing your production is very important. Work accidents and wear and tear on workers is something that is seen also because, when you have workers working with machines, they tend to get tired and so on, and they make mistakes ultimately. And limited workspace is another reason why automation has been very difficult in the past, because industrial robots and pneumatic setup and all this kind of thing tend to take up a lot of space. So what are the benefits if you look at collaborative machine tending instead? As I said, you can basically automate one application at a time. You don't need to basically automate the full production at one go. Just one simple task at a time. So you don't need to worry about too huge an initial investment. You can start with one application, make your ROI, and then look at the next application. As I already mentioned, cobots and collaborative applications, collaborative end effectors are for the most cases very easy to set up, very easy to program. I mean, we have production line workers that are now able to program collaborative applications without having an engineering background or things like that. So that is another benefit, where you don't necessarily need to worry about constantly having to have engineering or system integrators or coming in to do programming for you and spend a lot of time and money on that every time you need to change a process or need to change a product. It takes up very minimal workspace in the production. So as I said earlier, one of the key issues in the past is that taking up a lot of workspace in small manufacturing spaces is an issue. But cobots particularly takes up very limited space, which is again a great thing. Another thing, which is where we talked about the flexibility, which I mentioned earlier. The thing with cobots or collaborative applications is that cobots in general can be easily moved around from different production processes, right? So if you suddenly have a bottleneck in a certain applications, you can actually easily move the cobot to that specific process. Maybe you need to do some reprogramming of the end effector, or you might have to change the end effector, but the time is limited, and you can, as I say, you can easily move it around without much headache. So that's another huge benefit you are getting with collaborative cobots and collaborative end effectors in general. Another thing, and this is where I say particularly end effectors coming in, excuse me, is that collaborative end effectors are very smart. They can easily handle high mix, low volume production. So for instance, which I'll talk about a little bit later with OnRobot end effectors, all our end effectors are flexible. They can be changed, to different force, different stroke. You can change the fingertips, etc., etc. So basically, with the one gripper, you can handle multiple types, shape, size, weight of products. So high mix, low volume can be overcome with flexible end effectors. If you take your workers, and these can sometimes be very skilled workers. You have skilled workers working on just feeding machines. it might be also a good idea to, as I say, automate that process and give those workers time to do something that has maybe a higher value in your production. So that's another benefit to looking at collaborative automation. A lot of companies are thinking, okay, we have to let employees go, and okay, for some companies that's the goal, but from other companies they don't want to do that because those are skilled workers. So by doing collaborative application, they can learn how to handle these robots and end effectors and learn how to do programming and so on. So they actually increases their skill, but at the same time they'll also have time to do, as I say, other tasks in the production area. Of course, you'll minimize the risk as worker accidents because the robot is doing the difficult part, the dangerous part of the job. But you also tend to increase worker or employee welfare and satisfaction. Of course, you have more satisfied workers, less accidents. You will also have more motivated workers, which again is a benefit for you as a manufacturer. You also tend to increase quality and minimize scrap, right? So again, you have workers working 8 hours, 10 hours a day, maybe in multiple shifts, right? As a human, you get tired, you lose concentration, accidents happens, and so on. Or you drop things and you have maybe a higher percentage of scraps than you really want to. So that's another benefit to this ability to work 24/7. So that's another benefit of a cobot. It doesn't get tired. You can just let it run, day in, day out, 24 hours a day. Whereas workers, you either need 1 shift, 2 shift, 3 shift. You might have in temporary workers, and you might not be able to work during the weekend, and so on and so forth. But basically, you can increase your output by using collaborative applications. And last but not least, one of the benefits I think with cobots or collaborative applications is you can easily increase your cycle time. And especially here you see a Doosan cobot with our 3-finger gripper, but it's a dual setup where you use 2 grippers on 1 robot. So basically one gripper will insert the part that needs to be machine tended. Once it's done, the other gripper will pick up the finished part, turn around, put in another unfinished part, and once it's doing the CNC machine tending, it will drop off the finished part somewhere, pick up another unfinished part. By the time it's back up, it will do the same again. So you can actually save 40 to 50% cycle time. And if you have a CNC machine costing maybe $500,000-$600,000 US, saving that cycle time is a lot of money. So it's not only it's not only on the cobot application you need to look at the ROI. It's also, for instance, in this case, your machine tending machine. So go into our products. So as I said, OnRobot is making many different type of products. So I just mentioned the RD2 gripper, which you see here, which was the only gripper we had when I joined. So you can see kind of the growth we had over the past just under 4 years. Majority of our products are still grippers. We have many different kind of grippers. We have Fourstrike sensors, we have vision, we have certain processing tools like screwdrivers and sanders. I'm not going to talk about that today because it's not really relevant to machine tending. And we have our quick changes as well. So just to briefly explain how our system works. So all our end effectors comes with what we call a quick changer. So in this case, it's a manual quick changer. So we have a quick changer robot side, which you will screw onto the robot arm. Then any of these end effectors you can just click in to the quick change the robot side, and by the push of a button you can just change between different kind of end effectors in seconds, literally. So today you might want to use a 3-finger gripper, tomorrow you might want to use a parallel gripper, the next day a soft gripper, etc., etc. So you can very easily, without having to unscrew anything, without having to change cables, etc., you can basically change your end effectors for different applications in seconds. As I said earlier, we have the dual as well, so you can mix and match different type of grippers. You can have an electric vacuum gripper with a 2-finger parallel gripper for the same application as an example. So we have really made it very easy. So generally speaking, one of the things that I think is one of the challenges when companies, especially companies having multiple process with different kind of robots. You know, some might be cobots, some might be industrial robots, etc. They tend to have, you know, many different products from different suppliers. Sometimes they're bespoke end effectors. They use different kind of software. Sometimes software from different different suppliers are classing, etc. So there's not really anybody giving a system. They're just selling you products. So what OnRobot is doing, we're basically selling you a system. So one of our taglines is called One System, Zero Complexity. So you can use any of our end effectors on any robot brand, cobot or industrial robot in the same way with the same software. That is simple. So if you have multiple robots in your production hall, as I said, it could be Yaskawa, a light industrial robot, and a Doosan cobot. You can actually use the same end effectors mechanically and software-wise on the different robots. So that's a huge advantage as well. So it's taking a bit of time, so I'm going to go through this a little bit fast. So our first two-finger grippers, we have the RD2 and the RD6. 2 stands for 2 kilo payload, 6 for 6 kilo payload. But as I mentioned earlier, one of the key things with these kind of grippers is that, first of all, they're intelligent. They're electric, and what I mean by intelligent is that it can give you feedback. So if some of you are looking at Industry 4.0, for instance, that is actually a requirement for you to be able to get feedback, not only for the robot, but also from the end effectors. So just using let's say a basic pneumatic gripper will not be able to give you access to that. So this is another benefit with these kind of grippers. But another thing is, as I said, you can control your stroke, you can control the force. You can change the fingertips here. You can just 3D print them and make your own fingertips. Here's an extension shown. So what that's give you is it gives you access, as I said, to easily use the same gripper for many, many different product types, product sizes, product shapes, product weights, rather than having to buy and integrate a different gripper for every single new product you're doing. So high mix, low volume, this is where the benefit comes in. And of course, there's a lot of safety features in here. We have safety buttons here, which are PLD Cat 3 safety. We have safety shields here, so you don't get your fingers stuck inside and so on and so forth. So you see here round shape, so basically you're not going to cut yourself if it hits a worker when it's operating. Here's just an example of our dual setup. This is from a machine sending application, and this is from Sweden. But you can see how you can use two grippers in the same setup. This is our 3-finger gripper. This particular gripper is IP67 rated, so particularly good for dirty environments, which machine sending often is. It can take up to 15 kilo form fit, or otherwise 10 kilo payload. So quite a high payload as well. As you can see on the shape of here, the way it closes is particularly good for round objects. So again, as an example, you might have different types of objects. Some are square, some are round. So you can actually mix and match our grippers, 1 2-finger for square, 1 3-finger for round objects. So you can mix and match that as well on the same robot. And again, software, it's very easy. It's very easy to install. You can do it in minutes rather than having to integrate. For instance, if you use pneumatics, you have the air supply. It's a lot of maintenance. It takes time to set up. Sometimes air supply is unreliable. So you have there might be safety issues that things are dropped and so on. All this you're avoiding with these kind of products. We have our 2FT7, which is a parallel gripper. It's also IP67 rated, and it's also classroom ISO, clean room ISO class 5 certified. In case you are, you put it in a clean room area, for instance, a lab or similar. It can take up to 11 kilo maximum payload. And also, again, because it's IP67 rated, of course, it's also very good for harsh environments. And similar to the others, you can fully control your stroke, you can change the fingertips, you can control the force and so on. So it's very, very, very flexible. This is our latest products. We launched this, I think, back in March, if I remember correctly. So this is our MG10, which basically is our magnetic gripper with a 10 kilo payload, similar to the last two grippers. They are IP67 rated, so also again great for things like material handling. But this could also be particularly great in things like picking up sheet metal, from machine bending and so on. And one of the key things with this particular gripper is that you can actually fully adjust the force. So as an example, if you have a stack of say 100 sheets with other pneumatic grippers, it can be very hard to control the force. So you might end up picking up 2 or 3 or 4 sheets in one go, whereas with our gripper, you can actually pick up easily 1 sheet at a time. We also have a proximity sensor. You might be able to see a small sensor here, so you can sense when there's a part that you need to pick up, and once they sense that, the suction or the magnetic force will be turned on, and it'll pick up. So again, it could be great for different kind of machine tending applications. Then we have different kind of electric vacuum grippers. The first two is the VG10, which the guy you're seeing here. And then we have the smaller unit, which is the VDC10. Both of them are quite versatile. As I said, they're both electric, so you don't need to worry about air hoses and so on, and pneumatics and all this kind of thing. It's basically out of the box, install them on the robot, and you're good to go. Now, the key difference is that the VD10 here is where you can see they have 4 arms, which you can either close together like this, or you can open them up if you have a bigger piece of bigger material you need to pick up. So that's the flexibility you have in that. You have an A side and a B side. So 2 arms are the A side, 2 arms are the B side. So you can actually pick up 2 products at the same time. The difference with the VDC10 is that basically what we did was we picked off these 4 arms to make it more flexible. So the key thing with the VDC10 is that you can literally tailor make any adapter to it, depending on the shape or the size of the item you want to pick up. Here's a couple of examples. This could be, for instance, for bin picking. This could be for picking up a box. This could be picking up more curved items like a visor for a motor helmet shield, as an example. So you can totally tailor make the end effector to fit any shape and size. Again, out of the box, very, very flexible, no compressed air, and very, very cost effective. This is also one of our newer products. We launched this beginning of this year, which is our VGP20 electric vacuum gripper, which has the highest payload in the industry of an electric gripper, so maximum up to 20 kilo. Again, it's super versatile. In this case, rather than 2, it has 4 different channels, so A, B, C, D, which you can individually control the 4 channels. So you can pick up, for instance, 4 products in one go, but you can also remove all these, and you can actually tailor make, similar to the VDC10, you can tailor make your own adapters to fit, bigger products or different shape of products as well. But again, very high payload, no compressed air, very cost effective, and very easy to use. Then we have Fourstrike sensors. Fourstrike sensors are sometimes used in machine tending as well. We have actually sold some in India as well for CNC machine tending. It's more where there's maybe a very tight fit to fit in the product. Then Fourstrike sensors in particular can be very useful. Ours are optical sensing, so we are the only manufacturer in the world that is using optical sensing. So basically, the black part you're seeing here is silicon. So what does that mean? It means that we're using light emitters which are inside here, so you don't have it's not affected by electrical noise, which is done by normal what do you call it, Fourstrike sensors. Again, IP67, so great for dirty environments. The last product I want to talk about is our, we call it the EYES, which is our vision system. It's one of the very few 2.5D vision systems in the market. So if you're not familiar with the difference between 2D, 2.5D, and 3D, so most of you for sure know a 2D camera. So basically the half D basically means you get the set coordinate. So that means you can measure the height of an object. So things like if you have different items in different heights, normal robotics, you would need to, you need to set, what do you call it? You'll need to set the height for the gripper where to pick it up. So waypoints. But with this camera, you can actually, you don't need to do that. The camera will tell you the height of the product you're picking up and tell you exactly where the gripper should pick it up. So that's a huge benefit. It can be mounted on the robot arm. It can also be mounted externally. So that's another benefit to this. And of course, you can use it. You can use it for inspection and so on and so forth. But for machine tending, it can also be very, very useful. Shiv Kumar, where are we on time? We are about half an hour, I think.
You've got under 5-6 minutes, or please go ahead.
Okay, all right. So let me just show two quick success stories. They're both from machine tending. One is from Denmark and one is from Sweden. I think I'll just skip all this and I'll just go straight to the video. I hope. Let me see. Nope. For some reason, it's not working. Give me a second. There we go.
We are not able to hear the audio. We can see the video though. I think when you share your screen, you will.
Yeah, I forgot. Okay, let me just stop. Hang a moment. Hang on. Hang on. Can you see my screen again?
Not yet.
Okay, let me try again. Oh.
Yes, I can see your screen now.
Yeah, just hang on. It cut off. Now?
Yes.
Okay, let me try again.
Osvald Jensen is an over 100 years old company who's developed and produced transmission parts for a wide range of industries. We produce high quality worm gears, gear wheels, worms and gears here at our factory in Denmark. We maintain a close dialogue with our customers through the design and development phase to ensure we arrive at the right solution, the right quality and the right price. The collaboration between Osvald Jensen and OnRobot started when OnRobot in the developing phase needed consultancy, professional discussion and adjustment of the gears in the gripper. OnRobot experienced problems and contacted therefore Osvald Jensen, whose profile is to be a solution-oriented business partner regarding gears and gearboxes. We can first of all advise in developing phase, 2, be a partner in the prototyping, and 3, be a manufacturer in the serious production. We solved the problem for OnRobot, and actually today we are using the gripper in our daily production. To stay competitive in a high-cost country like Denmark, and at the same time demonstrate we are a modern company, we have decided to invest in technology that gives us the best return. We have invested a lot in our CNC machines, and with collaborative robots, especially the OnRobot gripper, we can in a very cost-effective way automate them. Therefore, in 2015, we invested in our first OnRobot gripper, and had a return on investment in less than 3 months. The machine operator has also been relieved from tedious work, and the machine can now continue working when the operator has left the workshop. In the meantime, OnRobot has developed a dual gripper solution, which compared to the single gripper, increases the productivity on the CNC machine simply by being able to handle 2 objects at the same time. We realized that with yet another cost-effective investment, we could improve our productivity even further. To sum it all up, we intend to invest further to ensure that we take full advantage of the collaborative robots.
Yeah, so I think you, first of all, the grippers you're seeing here is our version 1, where we didn't use the quick change, so it looks slightly different than the current versions. But I hope you paid notice of the difference between a single gripper and a dual gripper setup on one robot, and how you can really cut down the cycle time, which is what I talked about before. So that is, I think, is particularly helpful in machine tending applications. So I'm just going to do one more video before I stop, which is from FT Production, which is a Swedish machine tending company. All right, that's it for me.
Good. Yeah. Thank you very much, Niels, for the wonderful presentation. I hope the participants were able to understand the different products of OnRobot, and there were also some very good insights given on how collaborative robot application work and what you really look at safety, and it's just not the robot alone, and the end effectors also have to be considered. Great, thank you. And let me share my screen. Okay, and for the next part of the presentation, I will make a quick presentation about MELSS and the offerings that we have and how we integrate the overall solution. So I am Shiv Kumar Srinivasan. I'm the Chief Operating Officer at MELSS, and I head our different business groups, and I've spent quite a number of years in our industrial automation solutions, as well as in providing digitization and Industry 4.0 solutions for a wide variety of industries. Great. I see that there is some problem some of the participants are having with the chat itself. Just after this session, we will open up the option for people to unmute themselves and ask questions, and I think we could go ahead with this just after. Okay. Great. Okay, so good morning again, and so we'll run through the next 20-30 minutes on applications, what MELSS can do. So MELSS, we ourselves, as a quick background, we are an engineering technology company, and we are about 26 years old. We have 135 employees in our organization. We are headquartered in Chennai, and we have branch offices across all the major cities in India, as well as specific sales and support people in different parts to cater to our customers' needs in the local regions. Broadly, MELSS operates in 3 business verticals. The first handling electronic solutions, as well as products for reliability testing and in the areas of telecom and photonics. The second business group is from the industrial automation group, handling solutions for robotics, IIoT, MES, material handling solutions, and weighing batching solutions. The third business group is the electronic systems group, where we provide solutions for functional testing, ATEs, as well as we do a lot of projects for the defense and the public sector units. Our head office is located in Perungudi in Chennai. And we are an ISO 9001 certified company as well as an ISO 27001 certified for information security management. Focusing more on the industrial automation. So MELSS presents itself as a turnkey solutions provider to all our customers. So we are not a catalog product seller where we say this has to be free. We have a whole suite of solutions that we can offer and we can integrate. Be it the mechanical area that we deal with different type of robotics, unit and bulk handling conveyors, or it's to do anything with motion control or pneumatics or hydraulics, we take care of that. We offer complete control system solutions. It could be PLCs, IO links, sensors, and the required instrumentation to get your projects completed. And we've got a strong team handling the industrial software for the IT and OT integration. It's not just with the SCADA and HMI, but we also go up to the level of providing complete tracking traceability solutions along with barcode and RFID. So normally our projects start with what we call as a project conceptualization, where we come up with the entire project the customer requires on a 3D platform, including all the physical locations of where people are to be placed in the overall project setup, how you will have material movement, where the safety guards are required, including robotic cells and simulating them. So the automation software team at MELSS, we have completed over 1,000 projects over the year, and we've got a team of close to about 45 people with different skill sets put together to provide such solutions to our customers. We offer complete bulk material handling solutions. This is more in terms of powdered material and granular material that needs different type of material handling, weighing, batching, bagging, mixing, and so on, along with necessary dust collection equipment that goes onto it. A few photographs of the different type of projects that we have done in these areas. I'll kind of skip them pretty fast because we focus on the robotic activities here. We also offer unit handling solutions. These include different type of conveying solutions. It could be belt, rollers, different type of fixtures that are required for you to move your parts, along with, let's say, turntables, direction changers, scissor lifts, any kind of equipment that is required to handle the material in terms of its movement. And we also integrate with packing equipment, let's say stretch wrappers, shrink wrapping machines, or strapping machines that may be, or carton erectors that may be required as part of your overall solution, along with online printing and labeling solutions. We also specialize in providing end-of-line testing solutions, which are either functional or endurance test solutions, which require high grade of accuracies, be it physical parameters, electrical parameters, or testing of signals and communication channels on them. MELSS also offers MES solutions for complete factory digitization, be it track and trace solutions, mistake proofing, Pokayoke, or providing OEE and dashboard type of solutions. And we have integrated and deployed our digitization solutions in several factories in India and overseas for complete digitization and MES solutions. So looking at the robotic solutions itself, which is the primary theme of today's meeting, MELSS works with a number of partners in this area. We work with Doosan for their collaborative robots and OnRobot for their end-of-arm tooling and the end effectors. When it comes to industrial articulated robot, we work with Yaskawa Motorman, as well as we work with Epson for the SCADA robots for high-speed pick and place applications or low payload applications. So let me go into a generic slide on why industrial robots. Now, when you talk about industrial robots, there's a lot covered by both Mr. Lee and Mr. Niels on what robotics can do for you and how collaborative robots work. Now, I think the fundamental question of why industrial robots are required also needs to be answered. We broadly classify the type of work that an industrial robot can be deployed in 4 areas. If your work is a dull job, which you say is repetitive, non-value added type of jobs, then we can deploy robotics there so that the manpower can be utilized in more intelligent activities. It could be the dirty jobs. When I say dirty jobs, jobs that require high fatigue, there are payloads to be lifted, and these are dirty jobs which it's not good for an operator to handle. The third would be the dangerous jobs. Let us say they are in toxic environments or environments which could have hazardous impact, including high payload applications, which could be dangerous for operators. And the fourth are the delicate jobs, where you require very high precision. And while human dexterity can never be achieved by robot as of today, I think the importance is that there are accuracies in terms of microns that are required in many applications, as well as when a human mind keeps doing the same high accuracy job over and over again, fatigue sets in and machines don't have that fatigue. So that's the advantage of going for robotics. You will all be familiar with a number of slides that you would have seen in the past in many webinars, which talk about the different statistics about robotics and robotic implementation across the world. I've specifically taken two slides which may be of interest for us. One is in terms of how robotics are being used in different industries. As you know, automotive is a leader in the use of robotics, followed by electrical, electronics, and then metal and machinery. And so this is the global utilization of robotics for different type of different industries. Looking at the type of applications, if you see, the number one utilization is in handling. We say handling, it could be handling of material in terms of transferring material. It could be also the machine tending part, then followed by the other applications. So MELSS, as I said, we work with Doosan Robotics for their collaborative robots, and given that Mr. Lee has already given the wide range of products that they handle, I will skip. And we also work with OnRobots for the different type of end effectors, which was already presented in needs. And MELSS, we are an OnRobot certified partner, and we are able to supply and implement any of the end effectors that are being handled by OnRobot. The different type of industrial robotic applications, they can broadly be classified under 8 different categories. They will be material handling, assembly, material removal, quality, machine tending, material addition, welding, and others. So if you see, most of the industrial applications would fall under one of these categories, be it whether it is a transferring, palletizing, or the different type of machine tending applications that we are talking about. So what can MELSS offer? So now that you have collaborative robots and you have the different type of standard end effectors, it's very good. So the time to market is going to be very fast. When I say time to market, the time for implementation is quite fast. You don't have to do complex design. So the RG2 gripper or a 3FG15 gripper has a lot of built-in functions, and you can configure them using a web-based console. And you are able to do many applications which in the past still required a lot of detailed engineering. And so MELSS comes into the turnkey robotics implementation in these 5 areas. While it is possible for many organizations with collaborative robots these days, a project is not as simple as getting a robot and putting it into place. We normally, like any kind of a project implementation, we need to do a detailed study first, understand the project requirements, and then do a clear design. And when we are handling different type of products, parts, the design and engineering becomes critical for you to be able to handle different type of parts, as well as looking at the payload, reach, and so on. So MELSS does supply this equipment by along with our partners, as well as we integrate any third-party other equipment which can be bought off the shelf, or they need to be designed and developed by ourselves. We then integrate. When we say integrate, it is not just the integration of the different parts, it also includes the integration to your control systems and the IT. And apart from that, we also offer support. As shown earlier, we have a nationwide presence and we are able to attend to our customers across India. So when we look at a robotic project, there are multiple things that we have to study in detail before addressing a project. Firstly, we look at the different parts and the variants. So it might sound simple that I have a single part, but we need to go up to the details of how many variants are there and what type of end of arm tooling is required. So is it a hot surface? Is it an abrasive surface? Can it crush under pressure, would vacuum work for it or not, and if I'm going to move it quickly, will it fall, will the gripper hold in place, and all this is very important. And again, when we look at the parts and variant, Niels was explaining about high variant, low volume applications as well. So if we are going to have different variants, we need to identify and make sure that the collaborative robot application that we are trying to put together is useful across all the different type of models and variants, or at least quite a number of them, which is a high volume for you. We also look at the payload. As you saw, collaborative robots come with different payloads, right from somewhere starting around 5 kg all the way up to 25 kg. And it's important that the right payload is selected along with the reach. We will go ahead across a few examples to see how the collaborative robots need to access different parts of machines and be able to do simultaneously different jobs. And all comes down to cycle time. I'm assuming that none of us are happy to implement a robotic solution and then we say that we will get only about 50% of the output what we used to get earlier when a human was operating the same equipment. So in these cases, study of the cycle time and ensuring the right mix of the robotics, the program, the interfacing, the auxiliary equipment that needs to go. So many times you need a lot of jigs and fixtures to hold the equipment properly, their parts properly. They need to be fed in, fed out of the system. There may be some conveyor requirements or additionally some extra fittings that need to go along with the gripper itself, including things like cameras and lighting. Safety, yes, while we are talking about collaborative applications, safety really, we say that, okay, it's very safe to work alongside a collaborative robot. But as Niels also explained, if you're really talking about a collaborative application, it's just not the robot itself, the arm and the end of arm tooling also needs to be considered. And broadly, when talking about robotic projects, if they're industrial robots or SCARA robots, you will need to fence them for operator and people safety at that location. Another very important point is ROI, or you talk about the payback. So robotic projects, MELSS helps you in identifying and getting a good ROI or a payback on your robotic project implementation. So not one size fits all. The same type of project cannot be deployed for every customer and said that the same return on investment can be achieved. It depends on the number of variants that you want to handle. It depends on how many people that you put on your application at the moment and how many shifts that you operate. So we calculate such things and we are able to provide an optimum solution for your requirement. Looking at robotic projects, again, they need conceptualization of how the different equipment is required. If it's an industrial robot that we are talking about, they need fencing, light curtains, sensors, and so on. We need to look at any obstructions that you may have in your application, or there are also situations where you have cobots that need to work on a line with multiple machines next to each other. So there are different kind of applications that we look at and we go into detailing of each of them. So let's look at a few application examples. Sorry, I probably have to reshare you the audio. So let's look at one of the application example here. So this is a project we delivered for a customer some time ago, where we have deployed a SCARA robot. Here it's not really a collaborative robot, but if you can see, the SCARA robot does a machine tending operation where otherwise an operator would have had to stand near this machine for many hours put together for picking and placing a part where the remaining part of the machine does different operations. Now, this is a typical machine tending application, we could say, but in this case, you also have to fence it. You need to ensure operator safety to be able to get a proper solution delivered, both in terms of cycle time as well as in terms of operator safety. Let's look at another application. And here we have a collaborative robot doing an activity of machine tending, where it is a Doosan collaborative robot, where it picks and places products from a conveying line where there are different small parts that need to be put on a laser machine, and then it goes for an optical inspection. So the advantage of a collaborative robot here is that it has the option to, it has a 6-axis, so it can bend, it can have slight tilt as required, and it can also continuously allow for access around the machine in different sides. So it's not fixed to a specific small reach. Let me take up a few other videos as well. So if you noticed in this application, there is again no fencing required. It's a repetitive job that had to be done all day long. It did require some amount of movement of the arm in different axes. You may not be able to do it purely parallel to the ground, but that's where the collaborative robots application comes in for machine tending. Let's look at another application as well. As you can see in this application, it's a kind of a legacy machine that is being utilized. And here the robot by itself is used to even press the push buttons on the machine so that the operator intervention is removed. So even if there are not capabilities for us to fully integrate with that machine, such actions can be done. Okay, this was a similar video that sorry, just one second. Let's take a look at this video, which was already presented by Mr. Lee a short while ago. But it's interesting to see on this application that one collaborative robot is being used for tending to multiple machines. Again, talking about ROI or a payback, we could look at realigning your shop floor in terms of the locations of your machines so that a single cobot may be able to tend to multiple machines as well. So this gives us a lot of advantages, and the advantage would be when using grippers such as OnRobot's grippers for such applications. The parts that are being handled on each of these machines could also be different. They could be of different dimensions. One may require a 2-finger gripper, or one may require a 3-finger gripper. One may require a vacuum gripper. So we also have the two gripper mounting provisions are available with on-robot grippers. So that advantage can also be got. So overall, when you look at it, it could be a highly optimized solution that can be provided.
이렇게 가동시킬 수가 있죠. 그래서 이제 2대를 추가로 더 도입할 계획을 갖고 있습니다.
Another application I would like to bring to your attention is the advantage that collaborative robots bring for machine tending. Unlike standard industrial robots, where let us say you have long cycle times of your machine operation. For example, there's a 10-minute operation or a 15-minute operation. We don't want the robot to be idle. And the advantage that collaborative robots bring to the table is that these can be put on a moving platform. They don't require a three-phase electrical supply. They work on a single-phase supply. They can be driven out of a battery, and they can be on a mobile platform and automatically move to different locations and tend to those specific machines. These are again very good advantages that we can get out of collaborative robots. Great. So thank you very much, and that was the end of my presentation. We can now take on any questions and answers that you have. Yeah, feel free to use the chat if you have any challenges on using the chat. The audio has been enabled. You can unmute yourself and raise your questions. Thank you. Mr. Vignesh, you have your hand raised. If you have a question, you can unmute yourself. Please go ahead. Okay, so there is a question from Mr. Kapoor, which is, what are the advantages of Doosan over UR? Mr. Lee, would you like to handle this question?
Yes, I will reply to these queries briefly. So you are also top. How can I say? UR is also this collaborative robot, and also I also admire their technology and this product. But comparing with the Universal Robot and Doosan Robot, personally, I would like to introduce. I think you remember or not. For our M and H series, we have a torque sensor, and also comparing with this A series. A series is comparing with the net by this Universal Robot CB series, and also A sensor series is can be compared to Universal Robot E series. So when we have a testing by this speed by this A series, at that time our robot is more faster, and also compared to this collision detection level, it is more sensitive than Universal Robot. So I think sometimes I will share to MELSS for this video. So sometimes if you need for this clarification at that time, you can find that with the shared video later. So briefly, so I would like to tell you one thing is we have more and large this lineup. So compared to this number of lineup, so we provide the choice to this customer by their requirement. And second thing is safety. So some of this collaborative robot model, then at that time our robot is more safe with this torque sensor and also this collision detection level. Then the other thing is the next level is this compared to this feature characteristics with this testing. Okay, so hope this is a suitable reply to your queries.
Yeah, so just to summarize, Mr. Kapoor, I think yes, in terms of range, Doosan Robotics has the widest range of collaborative robots. There are over 10 models available. The H series offers higher payload capabilities, which are currently not available in UR. We have 20 and 25 kg payloads as well. And the A series is much faster in terms of a comparison. I hope that answered your questions. Okay, Niels, there's one question from Mr. Nimba Jadhav asking about the 3-finger gripper, whether it's able to handle 32 kg payload.
Yeah, unfortunately not. So generally speaking, if you look at the past, right, when you talk about collaborative robots, initially they say anything about 10 kilo is not collaborative. Then we reach 15 kilo, 20 kilo, 25 kilo, 30 kilo, etc. But for OnRobot, our target market is basically 20 kilo and below. So that is where majority of the copper market is, and is also what we consider light industrial robots is also 20 kilo and below. So that's kind of our target market. Anything above that, we don't really touch. And also, I think another thing is that when you go into higher payloads, especially with end effectors, traditionally you will use pneumatic, not electric end effectors.
Okay. Yeah, Mr. Jadhav, I hope that answers your question. And okay, there's another question, Niels, and whether OnRobot they make customized grippers based on customers' requirements.
Yeah, we don't. What we do is, and I don't know how clear it came out in today's presentation. What we do is we do standard end effectors, but they are very flexible, right? So that's the whole idea behind it, that you can take one gripper and use for multiple products. But we are never going to go into bespoke grippers, because that's a completely different market. That's where you can use MELSS and as an example. They can build for you if need be. But I think for most applications, you are actually able to find one of our grippers that you can modify in terms of stroke, in terms of force or whatever, and you can actually change it to potentially fit your specific product or multiple products. So I hope that kind of answered.
Yeah. Okay. Yes, Mr. Kapoor. So if OnRobot, as Niels explained, doesn't handle customized requirements, there are several varieties of end effectors which may be able to handle quite a number of your requirements. But if there are very specialized custom requirements, you can contact us, and MELSS may be able to take up some of these requirements. Okay. Okay. We have a message from Mr. Manigandan Subhavanam. Yes, sir. So I think I'll probably ask the application to Mr. Lee. Mr. Lee, has Doosan done any application where they do fastener thread rolling? Any such applications is done? This is basically to load fasteners into the thread rolling machine.
Actually, I have to check to the other region for having this application. But widely, as I see this fastener thread rolling, it can be pick and place, I think. So with this integrated with the machine. So I think if there is no application by a Doosan robot, but it can be tested as a POC with the MELSS if the customer need. So is it okay to your is it okay reply to your question?
Yeah, so we will check if similar application is already done, then we can share it. If not, yes, as Mr. Lee mentioned, we'd be happy to do a proof of concept to do the trial, right, or a pick up place application. Okay. Okay, I see two participants, Mr. Vignesh and Mr. Narendra Kumar. You have your hands up, so you can unmute yourself and you may please go ahead and speak.
Good morning, sir.
Yeah, please go ahead.
Sir, is there any collaborative robots using company or any research regarding the dual-arm robots? Up to now, you have seen.
Speak a little louder,
regarding
please. Can you repeat your question?
Is there any dual arm robotics are using in the company? Up to now, you have seen only single arm collaborative robotics. If you have used any two arms working on multiple missions.
So far, no, not in India. We have a single arm robotic applications. Mr. Lee, do you have any projects or case studies where dual arm has been used, two arms to do some applications? Yeah. Mr. Lee, you're on mute.
Hello, can you hear me?
Yes, we can hear you.
Oh yeah. Could you give me one more, because there was some this technical issue. I missed this. Yeah.
The question was, has there been any dual arm, two arm applications that we have done with the collaborative robots? Do you have any cases for that?
Actually, Duram this Duram product we do not have. But if there is some plane, I think it can be realized, but it needs to be tested, as I think. But there is the similar cases using this universal robot in China, as I know. But if we use our robot A series and with this right weight, dead weight, then at that time I think we can be tested for this Duram. I think you consider not to the same Duram, and also you need to how can I say this function and also this efficiency by this Duram like a Duram using, is it right?
Yeah. So, Mr. Kumar, does it answer your question?
Okay. So how can you calculate the forces while handling the gripper on robots? You've seen multiple grippers. How can you calculate the forces while handling the component?
Yes, do you want to take up this question?
Sorry.
Go ahead, Mr. Lee. Okay. Anyway, it was a bit unclear, but I think he asked about setting the force on our grippers. Is that correct?
Yes, I think he is looking at calculating the force. Yes, on the gripper.
Okay, so we don't really. Well, it depends a bit on the gripper, but a standard gripper, even though you can control the force, it will not give you. Well, it depends a bit on the gripper. Some of them will give you force feedback, some won't. Like an RD2 and RD6, you can control the force via the programming, but it will not give you force feedback. If you use RD2FT, which has built-in Fourstrike sensors in the fingertips, for instance, it'll give you force feedback as an example. Even our 2FT7 can give you force feedback. So it depends a bit on the gripper, but all of them you can program it, and via the sensors inside, it will reach that specific force that you're programming it to. But it's not all of them that are able to give you force feedback. So I hope that answers the question.
Okay.
Thank you, sir. And regarding the mobile robots, we have seen that mobile robot which is moving to the machine. And, how you are calculating the dynamics, robot dynamics while moving on a mobile robots?
This is more dependent on the AGV unit itself that is being, or let us say the AMR unit that handles the movement of the robot. The robot by itself, as long as once you've gone into a stationary position, I think, and there is no vibration, I think the robot can take care of it. These robots are not very heavy, these collaborative robots. And so as long as they are mounted properly and the center of gravity on the AMR or the AGV that you are using is okay, there would not be a problem.
Thank you, sir.
So we'll go to the next question. We have Mr. Vignesh who's raised his hand. Mr. Vignesh, do you have a question? You can unmute yourself.
No issue. I got the clarity. No time. Hello.
Yeah, please go ahead.
Sir, can you hear me?
Yeah, now we
Sir,
can
no
hear
issues.
you.
I got on your clarity. Thank you. Thank you.
Okay. Okay. So we'll probably go to the next question by Mr. Rajiv Rajan. You have a question? You can unmute yourself.
Hello.
Please.
Yeah. Hello. How much temperature these end effectors can hold? Or if you want to unload some parts from the furnace where it will be more than 30 degrees, can it withstand? How much temperature it can withstand? All these grippers or the end effectors?
You said 30 degrees.
Yeah, it can be, yes.
Yeah, but 30 degrees is no issue. Basically, we we are same standard as the cobot. If I remember correctly, I think is it 65 degrees, I think, if I remember correctly. But it also depends on let's say the fingertips you're using, right? As an example, our RD2, RD6 comes with a I don't know, it's like a silicone fingertip. So if it's hot items, you might want to change, to a metal fingertip, for instance. But certainly 30 degrees is no issue whatsoever. Not for the robot and not for the end effectors. Not ours anyway.
So what you're trying to say is we need to use metal grips.
I would suggest so. If it's warm or hot items, I would not use, let's say, for our sake, for our standard fingertips. So basically, what you can do is you can just unscrew the fingertips. You can take them off. You can make your own. You can 3D print them. You can make them in metal, and you can fit them on easily. That's all you have to do. So you can tailor make that yourself very easily.
Yeah. Okay. Yeah. Thanks.
Thank you very much, Mr. Ali. So we have the next question, Mr. Prakasha. If you have a question, you can unmute yourself, please.
Hi, good morning. So this is Prakash from Door India. So I have one question, but might be this is not the right forum for the question, but still would like to put across my question. So is there any progress on Doosan robots in the robotic well station application, or any integrator who works with Doosan on the setup of the robotic well station? Just in case if I have knowledge.
What station are you referring to?
Well station.
Yes.
For the arc welding.
Yeah, so for welding, yes, we can use the Doosan cobot. There are several applications available and case studies available as well. We can share it with you. In India, MELSS is representing Doosan, and so we would be able to work with you on that.
Sure, that will be grateful. Thank you.
Yeah, we'll get in touch with you. Thank you.
Sure, thank you.
Yeah. Okay. We have a question by Mr. Dhanasekar Balakrishna. Sir, you can unmute yourself, please.
Good afternoon, sir. Sir, my question is whether a cobot from Doosan could be used for soldering process like point soldering or line soldering, provided that it has a repeatability is not that better in comparison with standard industrial robot. Okay. If yes, then what kind of standard controllers, which make controllers is compatible with the Doosan robots for soldering purposes?
Yeah. So probably I'll take this question, and MELSS, we have some of our own automated soldering robots as well as a standard unit. We call it a solder bot. We'll probably able to give you details. Yes, of course, Doosan robot can be used for soldering as well. It depends on the application. There are a lot of scripts that you can write using the Doosan application development. So that can be integrated, and of course there are IOs available. So we can do IO based communication to any controller which can integrate based on IOs. Let's say switch on, switch off. You may have a wire feeder and so on. So those controls can be done. Having said that, for standard application like point soldering, drag soldering type of applications, at MELSS, we have a standard solution for that, and I think we'll be happy to get in touch with you to understand your needs, and then we can propose a solution to you.
Thank you. Thank you.
Thank you very much. Another question. Anybody has other questions? Let's take a look.
I think there is one question in the chat setting.
Yes. Yeah. So the question is, okay, so we've spoken to Mr. Manigan in the past, and so here they make fasteners, and the fasteners are on a bin, right? More like a wheelbarrow type of a bin where the fasteners are dumped randomly. So how does a robotic pick and place in the same orientation that is required? So Mr. Lee, you had any answers?
So I think it need to be collaboration with the vision system. Vision system means this camera. So a robot will be able to handle the appropriate product this setting and according to this signal from the vision. So I think robot is working by this signal from other how can I say this device. So I think for this pick and place by this randomly this pick and place, I think it need to be cooperate with this vision system.
Maybe I'll just add in here as well. Generally speaking, I think in most bin picking applications, you need a 3D vision system. 2.5D is not enough. You need a 3D vision system. So as Mr. Lee says, the vision system will give feedback to the robot and whatever end effector they're using to pick the part correctly and to place the part correctly in the needed orientation. So that's generally how it works.
So, Mr. Maniganan, I hope that answers your question. So we would definitely need a 3D vision system to be able to look at the bin, so identify all the parts and then give this feedback back to the robot to be able to go to the specific point and angle to pick up the respective part. And of course, the right type of end effector is required to be able to pick it as well. Are there any more questions from any of the participants? Yeah, feel free to unmute yourself and ask the question. Good. I assume there are no further questions then. And if that's the case, I thank all the participants for having joined this session. I hope it was useful. I also thank the speakers, Mr. Niels and Mr. Lee, for having presented in this session and taking your time. Thank you once again, everyone. And if there are any questions, feel free to write to us and we should be able to address your queries. Thank you very much. Have a great day.
Thank you, Shikama. Thank you, everyone.
Thank you.
Yeah, again, thank you for joining all of you.
Thank you.
Okay, I think there's a question from Mr. Rahul. Maybe we can address it before we leave. Mr. Rahul, if you want, you can unmute yourself and you can take up the question as well. Yeah.
Hello, this is Rahul from TDK India Private Limited. Here we have an application of gluing two ferrite parts together. We have a small part and a big part. We have gluing it together. How this can be more optimized using the collaborative robot or the vision system, I want to know. We are using a robot, two robots together to do this process, but we want to optimize this process more.
Yeah. So okay. With this information, it might be a little difficult for us to address this question now. We need to understand a little more on your layout, the type of part that you're trying to glue together, and the complexity involved over there. But I think as MELSS, we'll be happy to look at this application and suggest some optimization there. our team will definitely get in touch with you, Mr. Rahul, and then we'll take it forward from there. Yeah.
Okay. Okay. Thank you.
Yeah. Thank you. Great. Thank you, everyone. Have a great day.